Yes, hi. I received this mutant hi-hats from someone from the internet, and there seems to be a problem with it. It is not receiving triggers on the open hi-hat section. There's a closed and open hi-hat section with individual input for the triggers. So you can choke it if you want. I just received it, just opened it up. First I'm gonna do some visual inspection, of course. And this is my tester module. I can power it up. And it generates some gates and audio and frequency analyzers if you wish. It's a thing from Mutable Instruments, a DIY thing. There's a power ribbon coming out, and I just need some jacks to hook it up. The yellow wire on the left is to a speaker, so I can preview the audio coming from the module. So here I'm hooking up a gate pulse from the module tester, and I'm putting it in the open hi-hat section. And I thought it was supposed to work, that it was the other side that wasn't working. So here I'm thinking, this is the working side. I can see the LED blinking. Now if I put some audio in, we can hear a hi-hat. It's the closed. I don't know this module, it's the first time I have it in my hands, so here I'm testing it out. I'm not sure what it does. There seems to be a filter, it's actually quite nice. A drive. And now for the other side. And indeed, it doesn't work. Of course, this doesn't work as well, but you never know. I don't know this module, and I'm just trying to understand how it works. Think some more. Yeah, what I'm gonna do. I'm already thinking about sending in a quick pulse and trace the signal with the oscilloscope to see where it ends, but well, let's do some more visual inspection. Maybe it's just a cold solder joint and needs a little touch up on the socket. After all, it could just be the socket for the jack. You hear me thinking in the background. But before I test with the oscilloscope, I thought, why not test for some continuity? See if signals come through, if traces are interrupted or whatever. So whenever 2 points meet, the meter makes a bleep. That's connected, but the other side is also connected. There's 3 pins coming from a jack, this type of jack, and they're all connected to the tip of the audio jack. I'm gonna reference the other trigger input, but this is different. Only the ground is connected to the sleeve and the tip is connected to the tip of the jack. So now I'm just testing the socket itself, and I'm noticing all 3 points are shorted together. That's not how it's supposed to be normally, but hey, I don't know this module, I don't have a schematic, so here I am thinking, what am I missing? Is this the fault, or do I know shit about electronics? So I decided, let's take it apart and fast forward when I take these damn knobs off the module. These are a really tight fit and you have to be careful not to bend the front panel or anything or put too much stress on the pots themselves. Then you take them all off, one by one. It's a really tedious job. Now we have it open and we can do some more inspections. All surface mount components, obviously, really tiny stuff, not the smallest but tiny enough to need a magnifier, for me at least. I always keep the front panel next to it so I can reference what is what socket is for what, because it's not on the printed circuit board. And here I'm actually just doing the same as I did before, just to be sure, I guess. So I still see those two parts of the jack are shorted together. Now I'm trying to see, I'm suspecting it could also be an integrated circuit that's faulty. So I'm testing the power reels for a short. If the 12 volt is shorted to ground or the minus to ground, you should see a low ohmage. But these are all in the mega ohms, so that looks good. But still, there could be a problem with the op amps. So oh yeah, now before I check it, now I'm gonna see to what part the jack socket is shorted. So this is the good side and this all looks good. Only the ground is connected to ground, but here all three connections are shorted to ground. Doesn't tell me anything specifically, but hey, better know. Now since it's surface mount components, there's a small code on top, and this is an app I can use to check the code, and I can see the pinout of whatever component it's supposed to be. And this is an op amp, and these are, I presume, in the input stage to act as a buffer comparator kind of thing to make the trigger independent from what signal you're sending in. And it could be that they're broken, like from reverse power voltage or whatever. And I'm trying to see if I can see a pattern, if I can measure any short to ground or any of the power rails indicating a defect in one of the op amps. There's three, and since the printed circuit board is matte black, it's really difficult to see any traces, so I'm just trying them all to see if I can detect any pattern. But it doesn't make anything much clearer. It all seems okay. Ground is all ground and nothing else, and V plus is connected to the V plus reel, the 12 volt reel. Nothing strange. So here I'm already thinking, what step should I take next? These are the most obvious things before I start taking parts off. Because I actually already want to put in a signal that I know, a trigger, and follow it around. So here I'm setting up my oscilloscope and referencing it. First I'm gonna see if I can get some signal from my module tester on the oscilloscope, and the oscilloscope is just above the camera here. We cannot see it, unfortunately. But I can tell you, I can see a square wave, a pulse every 200 milliseconds, something like that. And now I want to follow this trace in the module to see where it stops. And I'm fiddling around, trying to see where I can put my earth prong thingy. And yeah, here I have some signal. This is the good working side, and this is the wrong side. And obviously, I get a flat signal with maybe a little bit of bump, a few millivolts, mostly. So here I'm thinking, oh yeah, I really have to take this socket off if I want to put in a signal in just the first pin. So I'm doing a final visual inspection. What's the solder look like? What does the socket look like? If it's going to be a difficult procedure to take it off, am I going to do this? I'm going to risk damaging the circuit board. And yes, I decide to risk it. Here is my solder sucker. Trying to find the right... but before I do that, you can tell on the board that it says ROHS, reduction of hazardous substances, which probably means this is unleaded solder, which needs much higher temperature and is a bitch to work with. So first I add a little bit of leaded solder, and I actually have to turn up my solder iron even more to make the unleaded solder melt, so I can add some of my own solder. That's what I'm doing here. And especially the ground lug takes a lot of time. Obviously it's sucking up all the heat from my iron. Wet the tip before I put it away. Good practice. So I'm already heating up my desoldering gun more, because I know it's gonna need the heat, but not too much, because it will damage the traces on the board. I really like this gun. Once I had it, I could never live without it again. So checking if I have the right one wouldn't be the first time. And sucking it out. And sucking it out. And it's never perfect the first time. There's always a tiny bit of solder that remains in at least one of the sockets. At first I tried to suck it out again, but it just is so little, there's not enough vacuum to suck it up, so I just bring in my normal solder thing and apply a little bit of heat, and it will just come off. And now there's one more, and I can feel it's only the tiniest amount of solder tin. So a little bit of heat should fix it. And here it is. So, and here I was. Let's try this socket, I thought. And would you know, there's a short in the socket. And obviously not on the board. The board is perfectly fine. There's no broken circuits or capacitors failing. And I'm trying to visually inspect the socket, but it's too close and too dark to see parts touching. I really couldn't tell. I really find it hard to believe, so I'm checking again. But yeah, here I am. It does happen, obviously. But it's stupid. Alright, let's clean the board with some isopropyl alcohol. I like to do that. The people at Mutant don't. If you look at the back, all the through-hole components are soldered with too much heat, in my opinion, and they didn't remove any flux. And it's the same with IntelliGel. It looks like shit. I would never ever deliver soldering like that. You just clean up a little bit after you finish, even if it were only to check the integrity and the quality of your soldering. And before you solder those parts back to the board, it's very important that you reapply the front panel so that all the hardware components are aligned like they should. So that's what I did. Screw it all back, and here I'm soldering 3 little through-hole legs. It's easy. Do some inspection and now measure it out. Again, well, those are no longer shorted together. So let's power it up. Put in a gate, and hey, there is a LED flashing already. And there is an HiHatting. Yeah, everything seems to work just fine. Well, yeah, that was an easy fix, indeed. I broke a socket. There it is. I'm throwing it in the trash before I accidentally use it in another project. Later I took it out to examine it even a little bit more. I cut it open to see if I can find anything, but I couldn't. Well, that's a roar of satisfaction. Repairing electronics, even this simple, it's great. It feels great. So let's put it back together, put it in the box. and send it back to where it came from.